Okay. Okay. So, insyaAllah, we'll begin with kita Al-Fatihah. Um, Bismillahirrahmanirrahim. Alhamdulillah, alhamdulillah, alhamdulillah. Sorry for the pendek lagu. Um, okay, I did ask in the chat apa, chat box about if you have um any topics particularly that you want to discuss. Um, so if not, then we'll go to this one question. Ada, ada. Uh, ada, ada, ada. Okay. So kalau tak ada, um, so this is kind of a revision. So previously, lastly, we talked about variation measurement and variation analysis. Um, so that is chapter 10. And then after that, we I think we talk about a bit on vibration modes. Um, Today, we'll go through just a bit on, I think in chapter 5, on force vibration. I think because we didn't really go through properly, if I'm not mistaken, especially on the steady state response. Yeah, we talked about steady state response before in chapter 5 and chapter 3, chapter 3, chapter 3, talk about it a little bit. But then the um, examples are a bit it's in slide mode. So in slides, so it's a bit it's really going to through the process of uh, developing the equations. Okay, so to go through that and okay, share. Screen. Boleh nampak ke? Is it not enough?
Yes, sir.
Yes.
Boleh nampak Boleh keluar.
Too small, sir. Just now better.
Oh, just now better. Sekarang better ke atau tadi lagi better?
Tadi lagi better.
Tadi lagi better. Okay. Now better.
Yes, sir.
Okay. 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 I think we're going to talk. It's going to be kind of a revision because we talked about this before. Just I want to point out a bit on the process itself. Okay. So now when it comes to steady state response. So basically there are two methods. One is in chapter 3, since we are talking about only single degree of freedom. In single degree of freedom, we can just sort of like for example, we can for 1 degree of freedom, we can just simply define the response as x. This response as x t u sine omega t. Okay, so what we need to do is we need to find the u. Okay, so this one you can refer back to chapter 3. We talk about this, but I'm going to go into 2 degree of freedom, where instead of defining the steady state response as just xt equals to u sine omega t, I will still do the same, but in 2 degree of freedom system or multiple degree of freedom system, we use the impedance method. Okay, so the impedance method is the one that we have z capital Z. We use capital Z or basically we are using the imaginary values to basically define the equation. So we'll go through that. If you want to look at the notes, it should be in chapter 5 on force. I think in force variation analysis, chapter 5. Okay. Now, so if we take one example, just snapshot. So if we take one example, it's not very clear. One example there, where we have is two masses, same mass, same K, x1 and x2, okay, with a harmonic force being applied on the x1, okay. Okay, so in terms of the process, so first thing first, what we should do is we should define the equation of motion. Okay, so maybe I'll just put numbering. Okay, numbering. So number one is EOM. Okay, so for the equation of motion, we can you can make it like two equations, and we have x1 and x2. Or we can also do it and for this impedance method, it's better to use matrix form. Okay, it's better to use matrix form. Okay. Matrix equation, because later on you are going to have to do inverse matrix. Okay. So so in the equation of motion, we can apply m0 m, right? Okay, so we have two equations, right? Then we can have x1 double dot and x2 double dot, right? Then plus, so this is the case, 2k minus k minus k and 2k. Okay. Somewhat x1 x2, right? Okay, so this one will equals to the input, right? So input was f. Over here it was f10 or f10. So we just put f cosine negative and 0, right? So input is in x1. There's no input in x2, right? Okay, so okay, so that's for the equation of motion. Now for the impedance method, we basically needs to define the position of the mass. Okay, so defining the position of mass is, for example, if we can define m, we can define as m11 and m22. So meaning we have the mass m11. We put the numbering because after that because you have k different position of k, so different position of k will reflect on the position of k on which side of the equation of the coordinate. Okay, so equation below. Okay, so M is we have M1 and M22. Okay. Um, then we have K equals to, for the K we have for the 2K. Okay, so 2K is the part over here. 2K. Okay. So 2K we can define as K1 1 and K2 2. Okay, so we have one position on 1, one position on 2. Okay, which basically defines the coordinate x1 and x2. Okay, and then we have a the k parts, or the negative k. So this negative k we can define as k1 2. Okay. Okay. Now, what else do we have? And we have f. We can also simplify f. We can simplify also f to be f1 is f, kalau kat sini buat 10 kan, f10 cosine omega t. Okay. Now, so when so when we want to proceed, again, as usual, as what we have done before, is we define the input or the response to be in harmonic response, right? Assume okay, response, so that will be x e max cosine omega t. Now, okay, since we are dealing with the numbering here, so we have M1, M22, we define in terms of the position. Okay, so we can also, in terms of the harmonic response, basically since there are two x, we have x1, x2, means it's 2 degree of freedom. So we can put j over here. So this j basically denotes either it's x1 or it's x2. Okay. Okay. Now, using the impedance method, so the impedance method, or impedance or mechanical impedance basically. Okay. So in mechanical impedance, okay, so the general equation for mechanical impedance is this one I think we did not talk in the notes. Okay, so the general equation for mechanical impedance is Q. It is using imaginary numbers. Okay, so minus omega squared mrs plus I WC rs plus K R. Okay, so R over here is as well R and S R, and S over here is 1 and 2. Okay, so this is the general equation. Now, if so, over here we do not have any dampers, so you don't have to deal with this one of IWCRS. So only omega squared MRS and KRS. Basically, it is similar to the one that we did before, with just the just the X, the apa, capital X, capital X kan, capital X equals to with it, and so since there is no C, so we are left with omega squared and K. Okay. Now, we can rewrite the mechanical impedance equation as Z the IW, the matrix of Z with the vector of X equals to vector of F0. Okay. Over here, the impedance matrix is actually that 1 1, that 1 2, that 1, and that 2 2. Okay, so nanti kat sini kita adanya kita ada impedance matrix, vector X pun ada kan, vector X. So vector X ni yang X1 dengan X2 lah. And kita ada F, vector F. So dia we have F10 and F20 means the input either at X1 or coordinate 1 or input at coordinate 2. Okay. So 0. Okay. So either, so it depends. Or if the input is in X2 or coordinate 2, then this one F10 will be 0 and this F20 will be the input. Okay, so it depends. So the one that we have over here is at coordinate 1. Okay. Now okay. Here. Okay. Okay, now. So so to continue, so we have our impedance Z over here, X and F. Okay. So using the impedance method from the equation. So since we want to have, or we want to find the the response. Okay. So response, it should be in X t equals to, so X cosine omega t, right? So this is the response. So this is the one that we want. Okay. So so from the impedance equation, we can rearrange. So Vx equals to, so since Z is moved to the right, so V I W, so this one will be -1. Right. So -1 vector F. Okay. So it's moved from this side to here. So you need to do inverse. Okay. So if we take the the Z matrix, okay, we perform in matrix. So Z I W in this one. Okay. So inverse matrix. So kena buat lah kan. So Z11 times Z22 minus Z12 times Z12 kan. Z12 okay. Z12 square. Okay. So and then this one rearrange lah kan. Z22 change Z1. So ini tak perlu. Z12 and negative. Z12 and negative. Z12. Okay. Okay. So okay. So we have this one, this equation. So we can put this equation. So we can see equation 1. Equation 2. Equation 2 kita masukkan dalam okay. Okay. So tadi tu, okay. So we have ini. So kita masukkan dalam equation 1. Okay. So we put this into here. Okay. And then kita ada X dengan F. So we arrange all the equations. So we will have one. Just write down the. Okay. So substitute 2 into 1 and we arrange the equations. Okay. So we'll have x1. So we have two x1 and x2. And capital x1 and x2. So this will be we'll have z 2 f0. Sorry, no f0, f10. F10. Tadi kita define f10 kan. Okay, f10. So f10 minus z12 f tak ada. Betul dia je dulu. Okay, so kalau ikutkan kat sini f20 tak ada. F20 is equal to 0. So if we rearrange the equation guna using this one, okay. Kalau just substitute since f20 tak ada, so but I'll just write down here. Z12 f20 over z11 and z2 minus z12 square. Okay, so this one is x1 and x2 buat benda yang sama lah. Doing the same thing, we get negative z12 f10 plus z11 f20. 1 z22 minus z12 square. Okay, so kita ada dulu lah. Okay. Yeah. Now, so since kat sini f20 ni tak ada, so boleh ya, boleh buang je. Okay. So dia akan jadi ni, so since f20 equals to 0, right? So kita boleh tulis balik lah. Okay. So tulis balik x1 is okay. So kita boleh just potong ni. Okay. So we have z22 f10 and z22 equals to z22 f10 and negative z12 f10. Okay. So yang dua ni kita boleh padam. Okay. So if we go back tadi to the general equation for mechanical impedance, so Z equals to negative omega squared m plus IWC plus K, right? So kat sini, since kita tak ada damper, so there's no C over here. So if we substitute, let me do it this way. Kita buat ini equation 2, equation 3, and then equation 2, equation 3. Okay. Ini kita letak equation 1. This one is equation 1. Okay. So from equation 1, okay. From equation 1, okay. So we can define Z11 and Z22 is equals to negative omega squared m plus 2k. Kan tadi kita ada negative omega squared m dengan k kan. So k kat sini k11 and k22. So k11 and k22 is equals to k. Okay. Okay. So we can substitute to equation 4. Okay. So we can substitute equation 4, equation 5, and equation 4. Okay. So this is equation 4. This is equation 5. Okay. We can substitute the cube. Okay. Equation 4. Sorry. 5 to 4. 5 to 4. So substitute lah. So satu lagi. Equation 5. Satu lagi is the Z12. Okay. So Z12 is another one with so the first one is with the this is for 11 and 12 11 and 22. Okay. So kat sini we define M11 and M22 M, K11 K22 is 2K. So another one is K12. So we have to take another one, 1, 2, put into the same equation, but the second equation. So the first equation is 1, 1 and 2, 2, the same numbers. The second one is only 1, 2. Okay. So since 1, 2 over here, we define a negative k. Okay. So kat sini tinggal negative k je. Dia tak ada sebab m is defined as 1, 1 and 2, 2. Kalau ada c pun defined as 1, 1 and 2, 2. So first one is 1, 1 and 2, 2. So 1, 1 and 2, 2 is 2k. Okay. So second equation, we have z12. So we take the k12. Okay. So z12 over here is only minus k. So this is equation 6. Okay. So then equation 6 and 5 to 4. Okay. So if we substitute into the equation, kita akan dapat x1 x1 and negative 1 omega squared m plus 2k f0 f10 over negative omega squared m plus 2k squared minus k squared. And the one x2 is k f10 over negative omega squared m plus 2k squared minus k squared. Sama. Okay, so once we have the x, okay, so once we have the x, so we can just put into the response equation. So you can either, if you want you can expand this one if you want. If not, just leave it like that. Okay, so steady state response will be x1. Okay, so x1 t and x2 t. We have two steady state response, right? So this will be based on x1 sine omega t and x2. Sorry, bukan sine. Tadi kita pakai cosine kan? Kita pakai cosine. Okay, kita pakai cosine. So since kita cosine, so this one gonna cosine lah. Okay. So cosine omega t, cosine omega t. So you can substitute yourself. So x1. So substitute this into x1 and substitute x2 into x2. You can write it down lah. Letakkan. Okay, so substitute them into the equation, so you have the steady state response. Okay, it will be so if there is dampers involved, then you have to include this one. You have to include this one. But then also you have to deal with complex numbers. Yang tu contoh dia ada dalam slide, if I'm not mistaken. Okay. Tapi finance exam tak adalah kita buat benda yang susah sangat in terms of mathematical procedures or mathematical method. So we focus more on vibration method instead of mathematical method. Okay. Okay. Okay, that's it. Okay, so do you have any question? Nah, cuba tengok adik tadi yang in terms of process tadi that we mentioned. So first, equation of motion. First equation of motion. Second will be defining harmonic response and mechanical impedance. Okay. So once you define that, okay, mechanical, okay. So once you define that, substitute semua equation, okay, and then steady state response. Okay, so steady state response equation will be similar to response equation, just that how you get X1 and X2 will be a bit different. Okay. So Alan, mau senyap je, okay ke?
Okay, sir. InsyaAllah.
Okay. Okay. So I hope you can do your own exercises. You can refer to the. I think I did put. Did I put the book? That's the punya book. Oh, tak ada. Let me share. So, but I think if you actually search for the book, for the textbook in internet, sebenarnya senang je nak dapat. Mana ni buku dia? book. Ya. Okay, sekarang tak lupa. Okay, boleh tengok dekat Microsoft Teams lah. Dia ada I have the PDF version of the book. Boleh tengok kat situ. Boleh tengok some exercises. Kalau boleh cari sometimes I think you can search for the solution. You search in the internet rasanya ada. Cuma which version I'm not very sure. So you can try to find lah. So the one that I shared with you is 5th edition. We are actually using 6th edition. Mana bukunya? I forgot mana tak. 6th edition. So 6th edition, I think the questions are quite similar. I think so. You can either way. So if you want, so if you are referring to the 5th edition book, so cuba cari 5th edition punya solution lah. If you're using 6th edition, cuba cari 6th edition punya solution. I don't have the 6th edition punya PDF. I only have the physical book. Okay. So anyway, that's it for today. So this will be the last and the final class. Okay, final class. So hari Khamis nak kahwin nanti kita tak ada garah. But of course feel free to ask question to Telegram. So ada apa-apa boleh tanyalah. Karima I target 1 week before final exam. So final exam nanti boleh 11 ke 13. Tengah. So tengah-tengah ni kan, tengah-tengah tak ada tengah yang kita. So I target to publish the Karima 1 week before final exam. So nanti boleh tengok lah kalau nak tengok. Okay. I will return your kalau nak ambil test test 2 test 1 and test 2 tak boleh marking lagi. So test 1 kalau nak ambil boleh ambil by the end of this week. Okay, hari Jumaat boleh ambil lah. Test 2 I think minggu depan lah, during revision week. Boleh tengok test 2 online kan, so boleh dapat kat online lah. Yang test 1 dia punya hak getah tu nanti I'll give you by the end of this week. Okay, and do not forget the project. By the end of this week juga. So yang tu boleh submit through Microsoft Teams. Nanti I'll put up the link for submission. So boleh submit dekat Microsoft Teams lah. So tak perlu hantar the physical paper. Yang physical paper tu you can keep it for your own revision. Okay. So tu juga. Okay, insyaAllah. So any question before we go? Ada eh? Okay. So kalau tak ada, so thank you very much for your participation throughout the semester. First and the most important things that hopefully everyone can benefit from the course. And also, I'm very sorry if there is any any shortcoming or any weaknesses in my delivery. So all the best for your final exam. Uh, do not forget with doa comes effort. Okay, so do not forget to put effort with doa, inshallah. Okay, so thank you very much. We end here with Tasbih Farah and Surah Al-Asr. اللهم أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. بسم الله الرحمن الرحيم والعصر إن كان ما في العصر إن الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر. Thank you very much, everyone. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.